Welcome to the exam walkthrough. We're going to be going to 2023 October, question number 22. So you can pause the video, try out the question. This is going to be from the electric fields. And if you want to see the mark scheme and the examiner report, you can go to the end of the video. So the question starts with the electron tube can be used to determine the specific charge, E over M, of an electron. A potential difference is applied between the cathode and anode to produce a beam of electrons. The beam is aimed at a fluorescent screen inside the tube and the path of the electrons is seen on the screen. There are two parallel metal plates above and below the screen. A and B are connected to these plates and allow a potential difference to be applied across the plates. And then it says, explain why the electrons are deflected in a parabolic path when a potential difference is applied between A and B. So to help us understand, I've drawn a diagram. Let's say these are two plates. This is a plate with lower potential difference, and this is a plate with higher potential difference. In a bit more simpler terms, this is basically the plate with negative charge, the plate with positive charge. And here we have the electrons that are passing through the plates. So now we're going to be talking about three things. Now remember, we can make it into two directions, the x direction and the y direction. Okay, so since it's following a parabolic path, we have seen this parabolic path term used in projectile motion as well, where we see two components, the components in the x direction of the velocity and y direction, and the acceleration in x direction and y direction, resultant force in x direction and y direction, and we see all of those things there. Okay, so that's the same thing we're trying to do here as well. Now, in the y direction, let's talk about y direction first because it has a lot more things going on. In the y direction, we can see that the electrons that are flowing through will experience an electric force. An electric force will be exerted on the electrons, and the electric force will be in the vertical direction, downwards. So yes, there's an electric force, that's the resultant force. So there is a resultant force in the vertical direction. And because there is a resultant force in the vertical direction, there is an acceleration in the vertical direction as well. And because of that, there is also a velocity in the vertical direction, and that velocity is changing because there is an acceleration. In the horizontal direction, there is no force. Okay, so there is no resultant force in the horizontal direction. So neither is there any acceleration, and the velocity is also constant. This is the same type of thing you have seen in projectile motion as well. The same things. It's just instead of the weight acting, we just have the electric force acting on the electron. So I hope that was clear, and all of this basically is the reason why the electron is following a parabolic path. So here I've just written it all down. Vertical resultant force is equals to the electric force on the electron. So the electron is accelerating in the vertical direction and moving with a non-constant velocity. Horizontal direction, resultant force is 0, so the acceleration is also 0, and the horizontal speed is therefore constant. So that's going to be your 3 marks. So it says in part B, a potential difference of 850 volts is applied between cathode and anode. Show that the maximum speed of the electrons as they emerge from the anode is about 1.7 times 10 to the power of 7 meters per second. So remember, the cathode is negatively charged and the anode is just positive. And the electrons come out from the hot filament lamp. And when they come out, they're going to gain kinetic energy. They're going to accelerate. And then they're going to have a maximum velocity once they leave the anode. So we just have to calculate how much kinetic energy they gained. And then from that, we can calculate the velocity using the formula, half mv squared. So the gain in kinetic energy is going to be equal to the work done due to the potential difference. So gain in KE is equal to work done by PD, the potential difference. And now we can write the formulas. Half mv squared is equals to the potential difference times the charge on the electron. And then you're going to solve it. You're going to plug in the value of 2 times the potential difference times the charge divided by the mass of the electron, and you're going to get the answer as 1.7 2.73 times 10 to the power of 7 meter per second, which is approximately what they gave you in the question. Remember to write it as 3SF because in the question they gave you it in 2SF. So part II is a 5-mark question. It says the electric field strength between the parallel metal plates is 1.7 times 10 to the power of 4 volts per meter. The length of each plate is 7.5 centimeter. The electrons pass through the region between the parallel metal plates. Calculate the vertical deflection of the electron beam. Basically, the vertical deflection, they just want you to calculate the vertical displacement. That's basically what they're telling you to find. Okay, and we know that the electron is going to come out of the anode with the velocity, which we found out before, 1.73 times 10 to the power of 7. And that's the velocity it's going to enter the metal plates with. So that's going to be the initial velocity of the electron. Now remember, this is the initial velocity in the x direction, not in the y direction. The initial velocity in the y direction is equal to 0. Sir, how can we say that? Well, if you remember, there was a question we used to do. It was, I like to call it the cliff question, where something falls off a cliff. We say that the u in the y direction is equal to 0 and u in the x direction is equal to the velocity that's of the object. That's the same thing what we're doing here. If you notice, it's kind of like the same thing. Okay, so the initial velocity in the vertical direction is 0 and the initial velocity in the x direction is what we found out before. So I hope till here it's all clear. Now, one of the major things we need to find here to be able to solve this question is the acceleration. In projectile motion questions, we already know the acceleration due to gravity, but here we have to find it out. So to find the acceleration, they've given us a lot of values to work with. So we know that the acceleration is F is equals to ma, and we know the force here, the resultant force is equals to the electric force. And the electric force is equals to the electric field strength times the charge. So now that I've explained you all of that, what we can do is we can equate the resultant force with the electric force. So we can say ma is equals to eq, and then we can make acceleration the subject, so we'll get eq over m. And now all I'm going to do is plug in the values and get the answer for the acceleration in the electric field. So now we're going to plug in all the values, and after we plug them in, we're going to get the acceleration as 2.99 times 10 to the raised power of 15 meter per second square. So now what we can do is we can use SUVAT, so S-U-V-A-T, and remember this is all in the vertical direction. For horizontal direction, we only have one equation, which is Sx is equals to Ux t, and this is for the vertical direction. So we want to find the vertical displacement. We know the initial velocity is 0. Final velocity we don't know. Acceleration is 2.99 times 10 to the power 15, and time we don't know. So remember, we have to know at least 3 of them to be able to solve. So we need to either find the final velocity or we need to find the time. And we can see that they have given us some other extra information. For example, they have given us the length of each plate. So they have given us the horizontal distance as 7.5 centimeter. And they have given us the initial velocity in the horizontal direction. So they have given me these 2 things already. So what I can do is I can find the time. So this is going to be the time taken for the electron to travel through the metal plates. So let's just find this out. So once you solve for t, you're going to get 4.34 times 10 to the power of minus 9 seconds. So now we know 3 of these quantities. We know speed, we know acceleration, and we know time. We know the initial speed, and we can just get rid of the final speed. So now we have an equation which has all of these, which is S is equals to ut plus half at square. So we can cancel this out here because your initial speed is 0. And now all you have to do is S is equals to half 2.99 times 10 to the power of 15. Just plug the values in and let's see what we get as the answer. So we're going to get the answer as 0.028 meters. Just write that answer, 0.028 meters. That's your final answer. Last part was a bit tricky, but it has come up before as well. So that's all for this question. Now I'm going to show you the mark scheme and the examiner report.